Hey everybody, welcome back to my channel. This is WireDogSec, and I'm back with another video for you guys. We are going to continue on with the Junior Penetration Tester learning path inside of TryHackMe, Introduction to Web Hacking section, and this room is the Authentication Bypass. Learn how to defeat logins and other authentication mechanisms to allow you access to unpermitted areas. Let's go ahead and dive into it. Task 1, brief. In this room, we will learn about different ways website authentication methods can be bypassed, defeated, or broken. These vulnerabilities can be some of the most critical as it often ends in leaks of customers' personal data. Start the machine, then proceed to the next task. All right, machine started. Let's go to task number 2 here, username enumeration. A helpful exercise to complete when trying to find authentication vulnerabilities is creating a list of valid usernames, which we'll use later in other tasks. Website error messages are great resources for collating this information to build our list of valid usernames. We have a form to create a new user account. If we go to the Acme IT support website here, sign up page. If you try entering the username admin and fill in the other form fields with fake information, you'll see we get the error an account with this username already exists. We can use this existence of this error message to produce a valid or list of valid usernames already signed up on the system by using the FF tool below. The FF tool uses a list of commonly used usernames to check against for any matches. So let's go ahead and get into this. All right, let's go ahead and navigate into Firefox here and then go to this sign up page they want us to take a look at here. So I'm going to copy this over into Firefox. Okay, so we got it all loaded up now. So if you were to try entering the username admin to fill in the other form fields with fake information, you'll see you get an error in account. If the username already exists, we can try to use existence error message to valid account, yada yada yada. All right, so let's go ahead and try this admin and then blah 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 at test.com, yada yada yada. Let's just do password 123. All right, there you go. Account username already exists. So let's go ahead and copy and paste this over into our terminal and see what it does. Copy all this here and open a new tab in this terminal. All right. Okay. Now, while that's going, let's continue on here. In the above example, the -w argument selects the file's location on the computer that contains the list of usernames that we're going to check exists. The -x argument specifies the request method. This will be a GET request by default, but it is a POST request in our example. The -d argument specifies the data that we are going to send. In our example, we have the fields username, email, password, and cpassword. We've set the value of the username to fuzz. In the ff tool, the fuzz keyword signifies where the contents from our word list will be inserted in the request. The -H argument is used for adding additional headers to the request. In this instance, we're setting the content type, so the web server knows we are sending form data. The -u argument specifies the URL we are making the request to. And finally, the -mr argument is the text on the page we are looking for to validate we found a valid username. The FF tool and word list come pre-installed on the attack box or can be installed locally by downloading it from this GitHub repository. Create a file called valid_usernames.txt and add the usernames that you found using FF. These will be used in task number 3. And I want us to answer some questions here. What is the username starting with SI, ST, and then RO? So let's go ahead and take a look at our output here. Hey everybody, just a quick little blurb here. As you can see here, most people that view my channel are not subscribers. If you're new here, Please consider subscribing to the channel. If you're enjoying the video, please consider hitting the like button. It helps get me in the algorithm, helps spread the good word out there, helps bring more people and increase our glorious community here. All right, I'm all about helping out others. I know what it's like to come up in cybersecurity or even try to get into cybersecurity and not knowing where to look. I'm just having this channel up so I can help out other people. All right, that's all I got. Here are our usernames. Looks like it's going to be Simon, Steve, and Robert, according to the output from this tool. And I've already launched this Sublime text editor and inputted those usernames inside of this file here. So this is already done. Let's continue on to task number 3, brute force. Using the valid underscore usernames.txt file we generated in the previous task, we can now use this to attempt a brute force attack against the login page here. It says note, if you created your valid user accounts or usernames file by piping the output from ff directly, you may have difficulty with this task. Clean your data or just copy usernames to a new file, which are already done. A brute force attack is an automated process that tries a list of commonly used passwords against either a single username or, like in our case, a list of usernames. When running this command, make sure the terminal is in the same directory as the valid underscore usernames.txt file, which it is. So let's go ahead and plug this in and start the brute force attack. All right, here we go. And looks like we found a couple here. The ff command is a little different to the previous one in task 2. Previously, we used the ffuzz or the fuzz keyword to select where in the request the data from the word list would be inserted. But because we're using multiple word lists, we have to specify our own fuzz keyword. In this instance, we've chosen W1 for our list of valid usernames and W2 for the list of passwords we will try. The multiple word lists are again specified with the "-w" argument, but separated with a comment. For a positive match, we're using the "-fc" argument to check for an HTTP status code other than 200. Running the above command will find a single working username and password combination that answers the question below. What is the valid username and password for this? Well, as we can see here, it's going to be Steve and Thunder. So let's go Steve and Thunder. All right, that's pretty cool there. Usually I would do something like this with a tool like Burp. I'm sure we're going to go over Burp later on as we progress through this pathway. All right, task number 4, logic flaw. What is a logic flaw? Sometimes authentication processes contain logic flaws. A logic flaw is when the typical logical path of an application is either bypassed, circumvented, or manipulated by a hacker. Logic flaws can exist in any area of a website, but we're going to concentrate on examples relating to authentication in this instance. And here's a infographic of what it looks like here. Hackers had bypassed these middle steps here and got straight to the ending step, to the step number 4. Logic flaw example. The below mock code example checks to see whether the start of the path the client is visiting begins with /admin, and if so, then further checks are made to see whether the client is in fact an admin. If the page doesn't begin with /admin, the page is shown to the client. And this is what it looks like here. Check. Showed code to check user is an admin in the view page. Because the above PHP code uses 3 equal signs, it's looking for an exact match of the string, including the same letter casing. The code presents a logic flaw because an unauthenticated user requesting -AD capital MIN will not have their privileges checked and have the page displayed to them, totally bypassing the authentication checks. Logic flaw practical. We're going to examine the password or the reset password function of the Acme IT support website here. So I'm going to go ahead and just copy this. We see a form asking for the email address associated with the account on which we wish to perform the password reset. If an invalid email is entered, you'll receive the error message, account not found, from supplied email address. For demonstration purposes, we'll use the email address robert@acmeitsupport.thm, which is accepted. We're then presented with the next stage of the form, which asks for the username associated with his login email address. If we enter Robert as the username and press the check username button, we'll be presented with a confirmation message that a password reset email will be sent to Robert at Acme, itsupport.thm. So let's just go ahead and follow through with this stuff. All right, and then said Robert was the username. So let's go ahead and plug that in there. There you go. At this stage, you may be wondering what the vulnerability could be in this application, as you have to know both the email and username, and then the password link is sent to the email address of the account holder. This walkthrough will require running both of the below curl requests on the attack box, which can be opened by using the blue button above. In the second step of the reset email process, the username is submitted in a post field to the web server, and the email address is sent in the query string request as a get field. Let's illustrate this by using the curl tool to manually make the request to the web server. So let's go ahead and copy this out of here, paste it over to the terminal. All right, so let's go ahead and just clear all this out of here. All right, and let's see here. We use the -h flag to add an additional header to the request. In this instance, we are setting the content type to application /x www form URL encoded, which lets the web server know we are sending form data so it properly understands our request. In the application, the user account is retrieved using the query string, but later on in the application logic, the password reset email is using the data found in the PHP variable request. The PHP $_request variable is an array that contains data received from the query string and post data. If the same key name is used for both the query string and post data, the application logic for this variable favors post data fields rather than the query string. So if we add another parameter to the post form, we can control where the password reset email gets delivered. All right, exactly what we wanted. So go ahead and copy this out. All right, now let's see. So we'll send you a password reset email to attacker at hacker whatever. All right. Uh, let's see if we can actually see that in here somewhere. That's what I'm assuming. You probably see this somewhere in here. Okay. And there we have it right here. So let's go ahead and continue on. For the next step, you'll need to create an account on the Acme IT Support customer section. Doing so gives you a unique email address that can be used to create support tickets. The email address is in the format of username at customer.acmeitsupport.thm. Now rerunning curl request number 2, but with the at Acme IT Support.thm in the email field, you'll have a ticket created on your account, which contains a link to log in as Robert. Using Robert's account, you can view their support tickets and reveal a flag. So let's go ahead and do that. Let's go back. And we need to register an account, right? So let's go ahead and sign up here. And let's just say, sure, WireDog. And WireDog with this particular email here. So let's go ahead and plug this in. All right, let's just do password 123. Very strong password here, folks. All right, so we signed in. All right, there we go. See, there's no support tickets or anything in there. Well, what happened? Okay, I was clicked the wrong thing here. But anyway, let's go back. And there's nothing in here. Okay, so let's go ahead and run this using my email account. So let's go back to this here, clear all this out. And remember, we have to go in and replace some things in here. So let's do that after I plug this in. All right. Now let's place this with WireDog. All right. Pretty sure that's what I set it as. Make sure. Yep. All right. So let's go ahead and launch it. All right. Now we're in the support tickets area here. As you see, I had to do it a couple times. But let's go ahead and click on ID4. And so this will automatically log us in. So let's just go ahead and copy this out of here and make sure to log out. And let's see. All right, it looks like we're logged in as Robert. Yep. So let's go ahead and check the support tickets to get this last flag out of here. There we go. And let's go ahead and continue on to task number 5, talking about cookie tampering. Examining and editing the cookies set by the web browser or web server during your online session can have multiple outcomes, such as unauthenticated access, access to another user's account, or elevated privileges. If you need a refresher on cookies, check out the HTTP in detail room on task 6, so check that out if you're interested. Plain text. The content of some cookies can be in plain text and it's obvious what they do. Take, for example, if these were the cookies set after a successful login, logged in equals true, admin equals false, etc., etc. We can see one cookie logged underscore in, which appears to control whether the user is currently logged in or not, and another admin, which controls whether the visitor has admin privileges. Using this logic, if we were to change the contents of the cookie and make a request, we'll be able to change our privileges. First, we'll start by requesting the target page. So let's go ahead and do that here. All right, so not logged in. Now we'll set another request with the logged in cookie to true and admin set it to false. So copy and paste again. Finally, we'll set one last setting, both logged in and admin cookie. So it should say logged in as admin. And there we go. And looks like we got a flag. So let's go ahead and copy this out of here. All right, let's talk about hashing, but let's go ahead and plug this in first. Let's see, this is probably the first one here. All right, now let's see here. Hashing. Sometimes cookie values can look like a long string of random characters. These are called hashes, which are an irreversible representation of the original text. Here are some examples that you may come across. And this is what they look like. Be sure to pause the video, check out this table here, familiarize yourself with how they look. MD5, SHA-256, or 256, SHA-512, and SHA-1. You can see from the above table that the hash output from the same input string can significantly differ depending on the hash method in use. Even though the hash is irreversible, the same output is produced every time, which is helpful for us as services such as CrackStation.net keep databases of billions of hashes in their original strings. Encoding. Encoding is similar to hashing in that it creates what would seem to be a random string of text, but in fact, the encoding is reversible. So it begs the question, what is the point in encoding? Encoding allows us to convert binary data into human readable text that can be easily and safely transmitted over mediums that only support plain text ASCII characters. Common encoding types are base 32, which converts binary data to the characters A to Z into to 7, and base 64, which converts using the characters A to Z lowercase, A to Z uppercase, 0 to 9, the plus sign, and the forward slash sign, and the equals sign for padding. Take the below data as an example, which is set by the web server upon logging in. Set cookie session equals yada yada yada, max age yada yada yada. This string base 64 decoded has the value of ID is 1, admin false. We can then encode this back to base 64, encode it again, but instead setting the admin value to true, which now gives us admin access. All right, so let's go ahead and try to find out some of these values here. So this crack station here, let's go ahead and copy this over and visit it from the attacker machine here, or the attack box. All right, so let's go ahead and navigate to crack station and plug some of these in there. First one's going to be ND5 hash, so let's go ahead and plug it in. No, I'm not a robot. Crosswalks, sure. Little captures. All right, crack check this hash here, and there's our answer. Go ahead and plug this in. All right, what is the base 64 decoded value of the following? So let's go ahead and try the same thing here. Let's see. This looks like a job for a cyber chef. Yeah. Let me reject this cyber chef. All right, as soon as this loads up, we'll take a look here from base 64. Go ahead and copy this over. There we go. I got that flag. Now this last one here, it wants us to says encode the following value using base 64 and then submit it. So let's go ahead and copy all this out of here. And this time we are going to bake it to base 64. All right, there we go. And this is what it looks like. Go ahead and copy this over. All right, that wraps this up. Hopefully you all found this video of value. And if you did and you're new here, please consider hitting the subscribe button with the notification bell so you know every time I upload a video. Also, thank you guys for watching. As always, hit that like button if you enjoyed the content. Comment below your thoughts and opinions on the information shared in the video. And I will see you later.